Hello everyone, my name is Xiaohan. I'm an applied scientist at Amazon. We are working on several projects for improving customers' experience for watching sport videos. Today we are going to introduce our recent work, a robust and efficient framework for sports field registration. Our goal is to estimate the transformation between camera image and the sports field. We have two assumptions. First, the field is a planar surface. Second, there is no prior knowledge about the camera. Then this transformation can be parameterized as a homography matrix. The biggest challenge for having an accurate sport field registration is the lack of sufficient distinctive features. This challenge can emerge from three sources. First, the uniform field appearance. Second, the narrow field of view. Third, the field occlusion. So in order to address this challenge, we detect a grid of uniformly distributed key points to find the initial homography estimation. Then we regress dense features to fine-tune this estimation. We also compiled a new dataset called sports fields from 5 sports, covering large environments and camera variations. So let's first talk about the key points. The traditional key points are defined on local corners and line intersections. They can be easily detected using local image patches, but cannot cover the whole field. So with our defined grid key points, we can easily cover the whole field with arbitrary density, but cannot be reliably detected using local image patches. So in order to overcome this challenge, we design a network with large receptive fields by incorporating dilated convolution and non-local block. So with our defined grid key points, we can easily apply the direct linear transform and ransack to have the initial homography estimation. But we can see from the two examples, the estimation is still not perfect. Then we propose to use dense feature-based online refinement. The dense features are defined as the distance of pixels to their nearest landmarks. Here we use two types of landmarks, the lines and the key regions. We first manually annotate the line map and the region map, and then we transform them to feature map by distance transform. With dense features, we can fine-tune the homography by optimizing two losses, the tracking loss and the matching loss. The tracking loss aligns the dense feature at frame t with the feature from t-1, and the matching loss aligns the dense feature at frame t with a feature from the field template. We use differentiable bilinear sampling to warp the feature. And this is the homography estimation pipeline. Given the image, we first estimate the grid key points and the dense features. Then we decide if we need to refine the initial estimation by the self-verification. We collected a new dataset called a sports field, which is covering 5 sports from 150 videos, and we have 2,500 annotations. And we achieved the best results on the Soccer World Cup dataset, and also we are running multiple times faster than others. And also we achieved the best performance on the American football data or sports field datasets. And we also achieved that over 95% intersection of union and less than half meter projection error on all sports or the sports field datasets. So in summary, we address the challenge of the lack of distinctive features by first detecting a grid of uniformly distributed key points to find the initial estimate. Then we regress dense features to optimize this initial estimate. And in order to have a comprehensive evaluation, we compiled a new dataset called a sports field to cover 5 sports with large environments and camera variations. So at the last, I want to show you some quantitative results from the 5 sports. So on the left, you can see the camera image overlaid by the field template. The green dots are the detected key points. On the right, I show you the coverage of the camera. So this is an example of basketball. So we can see that the camera is actually moving from one side to another side, and we are able to track the field quite well. So this is an example of soccer. So the soccer field is almost textureless, and with grid key points, we can still track the field accurately. And this is an example of ice hockey. So in ice hockey, the camera motion is larger than other sports, and we are still able to track the field. And the last example is tennis. The tennis is the easiest one among the 5 sports because the camera is almost static. So that's all. Thank you.